Hello, today we're going to learn how to factor polynomials completely. Factor polynomials completely. Okay, we have different polynomials. The polynomial we use the most is the trinomial ax squared plus bx plus c, just as this one you can see on here. But we have another ones. We have binomials. With the greater exponent than 2, we have trinomials, polynomials 4, polynomial 5, and we continue with the list of polynomials that are graders. On this case, that you have a trinomial ax squared plus bx plus c, you already know how to factorize it, because you factorize it with the scissor method normally. But when you have a polynomial that a greater degree is not 2, it's greater than 2, you need to use another method. And which is the method you can use? Well, it's looking for the greatest common factor. You look for the greatest common factor between each terms, but you need to make groups. And how you're going to make these groups? Well, when it's a binomial, you're going to make one group of 2 using both terms you have in the binomial. And you're going to take the greatest common factor between both. When you have a trinomial, you also make just one group. And you take the greatest common factor between the 3 terms you have in there. Now, when you have a polynomial of 4, it changes a little bit. You need to make 2 groups. And each group, you need to make it of 2. And you take the first 2 terms and the last 2 terms. How you know which ones are the first and which ones are the last? Okay, you need to arrange them from the greater degree to the lowest degree, just as you can look at on here, from the greater onto the lower. Now, when you have a polynomial of 5, it's also you need to make 2 groups, but you need to make one group of 3 and one group of 2. And this way, you will continue doing it. So, let's make some examples so you can understand that better. This example, we're working with a binomial. On this binomial, we need to find our greatest common factor. And the greatest common factor between 25x raised to the 4th power minus x raised to the 2nd power equals 0 is just x squared. Why is just x squared? Because as you can see, 25 and 1 are the values we have on here. And between 25 and 1, there is nothing in common. So we need to see in the variables which is the common factor. So the common factor between x raised to the 4th power and x raised to the 2nd power is x raised to the 2nd power. I divide everything on here with the greatest common factor. 25x raised to the 4th power divided by x raised to the 2nd power gives me 25x raised to the 2nd power. And negative x raised to the 2nd power divided by x raised to the 2nd power gives me negative 1. So this way I have x squared times 25x squared minus 1 equals 0. Okay, and here I factorize with my greatest common factor. But I'm not over in here because if I can see in the parentheses, I have a difference of squares. So I can apply my property that tells me that I need to find my factors of 25 and of 1. So I'm going to start factorizing my 25. My factors of 25 are 1 times 25 and 5 times 5. And my factors of 1 are 1 times 1. Well, now that I find my factors, I'm going to start looking which ones are the squares. So I can apply it with this property. And I see that the square numbers are 5 times 5 and 1 times 1. So this way, I'm going to use my 5 and my 1. And my answer will be x squared because I just write down my x squared and the two parentheses that I find with my difference of squares pattern. That I have my answer is x squared times 5x minus 1 times 5x plus 1 equals 0. Now, I already factorized it completely, but I have an equal 0. So when I have an equal 0, I need to place each of the terms equals to 0. So I have x squared equals to 0, 5x minus 1 equals to 0, and 5x plus 1 equals to 0. I start with my x squared equals to 0. So in here, I got that x equals to 0. Now, 5x minus 1 equals to 0. I take away my parentheses and I start moving my 1 to the other side. And if on here is a negative number, on the other side, it goes adding. So I have 5x equals 1. Now, what I need to do with this 5, if my 5 is multiplying, on the other side would go dividing. So my answer will be x equals 1 over 5. Now, I need to do just the same, but with the other parentheses. Now that I make it with the other parentheses, I have 5x plus 1 equals 0. I take away my parentheses and I move my 1 to the other side. This way, I have 5x equals negative 1. Now, I need to leave my variable completely alone, and I move my 5 that is multiplying to the other side, dividing. And my answer will be x equals negative 1 over 5. Now, I have two possible answers for my x. X equals 1 over 5 and x equals negative 1 over 5. Now, when I factorize a polynomial completely with 3 terms, a trinomial. Okay, I take just one group and I take the greatest common factor between the 3 monomials I have. I can look on here. 1, 7, and 12 don't have anything in common, but x raised to the third power, x raised to the second power, and x, they do have. And the greatest common factor in this polynomial is just x. So I divide everything by x. X raised to the third power divided by x equals x raised to the second power. Negative 7x raised to the second power divided by x is negative 7x. And 12x divided by x is 12. Now that I factorize it, I have a normal trinomial, and I can apply my Caesar method. So I'm going to start taking my factors of x, that the number I have in here is 1, and the factors of 12. The factors of 12 are 1 times 12, 2 times 6, and 3 times 4. And the factors for 1 are just 1 and 1. This way, I start applying my Caesar method. And I need to define how will be my signs. If I have a positive and a negative, and this one is positive, this means both numbers I multiply needs to be the same sign. So I'm going to use a negative sign because the one in the center is negative. Now, I use 1x and 1x for x squared, and 3 and 4 for 12. I multiply 1x times negative 4 and 1x times 3. And my answer will be negative 3x minus 4x. When I add these two numbers, I find negative 7x. And this is just the same value I need in here. So, when I got the value I find at the bottom is the same one I need on the center, this is the answer I need. This way, I'll just put down my x and I'll copy these two parentheses I find. when I factorize my trinomial. And I'll have x times x minus 3 times x minus 4 equals 0. Okay, I'm here. I already factorized it completely. Now, the only thing I'm missing is equal each of these terms I have to 0. So I'm going to place it x equals to 0, x minus 3 equals to 0, and x minus 4 equals to 0. Then I leave my variable completely alone. I move my negative 3 to the other side adding, and I move my negative 4 to the other side adding also. This way I have 3 possible answers for my x that are x equals 0, x equals 3, and x equals 4. On here we see how to factor a trinomial. Now we're going to see how to factor a polynomial of 4. In this case, we need to take 2 groups so we can factorize it with our greatest common factor. I'm going to take the greatest common factor of the first 2 and of the last 2. But the first thing I need to see if they are arranged from the greater until the lowest degree. In this case, I already have it arranged, so I don't need to touch it. Now, which are the greatest common factor between 18x raised to the third power and 9x raised to the second power? Okay, I take my greatest common factor, and my greatest common factor between these two is 9x raised to the second power. Now, between 32x and 60, which is my greatest common factor? My greatest common factor between 32x and 16 is negative 16. So, I place my greatest common factors and I divide them. I divide 9x squared divided by 18x raised to the third power, and I have 2x. 9x squared divided by negative 9x squared, and I have negative 1. Now, my greatest common factor in this 2 is negative 16. So I divide negative 32x divided by negative 16, and I have just 2x. And negative 16 divided by 16 is negative 1. And this way, as you can see, both of the parentheses we have in here are the same. So I can simplify it and add these two values, the 9x squared and the negative 16, in order just to have one parenthesis. And I'll have 9x squared minus 16 times 2x minus 1. This way, on here, I cannot factorize it anymore, the 2x minus 1. But I can factor my 9x squared minus 16 because I have a difference of the squares. So I start taking my factors of 9 and my factors of 16. And when I find that my factors of 9 squared are 3 and 3, and the factors of 16, the square ones, are the 4 and 4, I start making my pattern I have in here. And I'll have 3x minus 4 times 3x plus 4 times 2x minus 1 equals 0. From where I take the 2x minus 1, well, I just write it down. And the other ones is the factorization of 9x squared, and I just take the 3, and my 16, I take the 4, following my difference of square pattern. Now, I equal each of these ones to 0, and I start finding with the procedure my variables. I move my negative 4 to the other side as a positive, and I divide. And I find that I have x equals 4/3. I simplify it, and now I do just the same with the other one. 3x plus 4, and I have x equals negative 1/3. Now I do just the same with the 2x minus 1, and I move my negative 1 to the other side as a positive, and I have x equals 1/2. This way I got 3 different answers. X equals 1/3, x equals negative 1/3, and x equals 1/2. Okay, on this video we watched how to factor polynomials completely when you're using a binomial, when you're using a trinomial, and when you're using a polynomial of 4. So, if you have any doubt, you can leave it in the comments below, and thanks for watching.